In this video, we will show you how you can use Rafay's Terraform provider to manage the lifecycle of Azure AKS clusters. We'll break this down into typical tasks that operations and SRE teams have to perform over the lifetime of an AKS cluster. Rafay provides a verified Terraform provider at HashiCorp's Terraform registry. Let's first register the Rafay Terraform provider using the Terraform init command. We will start with day one, where we will configure and provision an Azure AKS cluster. We want the AKS cluster to be provisioned in a Rafay project called Terraform. Our AKS cluster will be bootstrapped with a single node pool. We will then apply version 1 of a custom cluster blueprint. Let us now apply the Terraform plan to provision our standardized AKS cluster. Once our AKS cluster has been successfully provisioned in the Terraform project, the custom cluster blueprint version 1 with the configured add-ons will be automatically applied, and the AKS cluster will be brought to the desired state. On day 2, we want to upgrade our AKS cluster's control plane and the node pool to the latest Kubernetes version, that is version 1.21.9 to version 1.22.6. Let us make the change in our main.terraform file and use Terraform apply to bring our AKS cluster to the desired state. The Rafay controller processes the changes requested via Terraform and performs the upgrade of the AKS cluster's control plane and the attached node pool. Once the process is complete, we can see that the cluster's control plane is reporting the new Kubernetes version. Let us access our AKS cluster using Zero Trust kubectl to check the Kubernetes version for the nodes in the node pool. On day 3, an application team requests for increased cluster capacity, and we decide to scale the node pool to 2 worker nodes. Let's make the change in our main.tf file and use Terraform apply to bring our AKS cluster to the desired state. The Rafay controller processes the change requested via Terraform and scales the node pool to 2 worker nodes. Once the process is complete, we can see that the Rafay AKS cluster dashboard is reporting 2 worker nodes in the node pool. We have another application team that would like to deploy on our AKS cluster. So we want to add a second node pool to our AKS cluster. Let's make the change in our main.tf file and use Terraform apply to bring our AKS cluster to the desired state. Rafay processes the changes requested via Terraform and adds a second node pool to the AKS cluster. Once the process is complete, we can see that the Rafay AKS cluster dashboard is reporting the third worker node from the second node pool we just added to the AKS cluster. On day 4, we want to update the cluster blueprint to a new version since one of the add-ons in the blueprint has a meaningful update that we want to standardize on across the enterprise. In this example, we want to update the ingress controller add-on from version 1.1.2 to 1.1.3 and revise the blueprint to the next version. Let's make the changes in our main.tf file and use Terraform apply to bring our AKS cluster to the desired state again. Notice that the new version of the blueprint has been created with the new version of the add-on in the project. In a few seconds, the cluster blueprint associated with the AKS cluster is also updated to the new version. On day 5, An administrator attempts to manually update the AKS cluster by adding a cluster label to the AKS cluster. Manual out-of-band changes like this make the cluster drift from the desired state captured in the Terraform state file. Administrators can remove this drift and bring the cluster back to desired state in just a few minutes. When the admin uses Terraform apply, it warns the admin that the current state and the state file are not in sync. It then allows the admin to bring the cluster back to the desired state by removing the cluster labels that were added without formal review and approval. On day 6, we receive a request from an application team for a Kubernetes namespace on the AKS cluster. Let us make the necessary changes in Terraform by specifying the details for the namespace. In this case, the namespace is called demo namespace, and as per company policy, we are required to specify resource quotas for the new namespace. Let's make the changes in our main.tf file and use Terraform apply to bring our cluster to the desired state with the new namespace. Notice that in a few seconds, the new namespace gets created on Rafay and is published on the remote AKS cluster.